Okay, ladies and gentlemen, welcome to this fantabulous screencast assignment. Um, Bear with me as we get through this. We are now on recording number 4, I believe, as the other ones have been either a failed attempt or lost videos. Yes, I know. Great situation for me. Anywho, so as you can see, my topic is statistics and probability. And before you moan and groan and cringe at me, take a deep breath because we're going to take it back a few grade levels to 8th grade. And when we're dealing with 8th grade statistics and probability, it's not as stomach churning as your college statistics and probability. So the learning target for this lesson is I can use the equation of a linear model to solve problems in the context of bivariate measurement data, interpreting the slope and intercept. So what this means is when you are given a scatter plot and a line of best fit, you want to be able to interpret it and know what it's saying and what, not just the mathematical context of it. You want to know what it's defining, what it means. So let's get started. We're going to bring it back to the basics a little bit. And by the basics, I mean, what's a scatter plot? And just as a refresher, a scatter plot, it's just a graph with the graph with the dotted data points. And we use scatter plots to determine how much one variable is affected by another. And the reason that we have scatter plots and we don't just plot a line right away is because sometimes the data that we collect is not always exactly linear or whatever. So we do this so that we can determine what that line is that would represent it. Which leads me to my next point, what is a line of best fit? And a line of best fit is a straight line that best represents the data on a scatter plot. The most common way that teachers typically teach this to 8th graders is they have them use dry spaghetti noodles, where they will place a spaghetti noodle on the sheet where they have the plotted data so that they can try and determine which angle and which way that line best represents all of that data, like what goes through the majority or what would be the average, so on and so forth. The thing with the line of best fit is that they can pass through either some of the points, none of the points, or all of the points. It all just kind of depends on where that data set falls. For example, if you're in a science class and you are doing an experiment where you want to know how long it takes for a ball to hit the ground when dropping it from different heights, obviously those data points aren't going to pop up in a necessarily perfect linear line, but due to several different reasons, but we can determine a line that would best represent that. And with scatter plots and these lines of best fit, we can determine, we can just kind of see the positive or negative correlation between the two variables. And by this I mean when a positive correlation is when your x variable is increasing along with your y variable. And with a negative correlation, your x variable is increasing, but your y variable is decreasing. How do you find the line of best fit? So like I said before, a lot of teachers have students use spaghetti noodles or rulers. The thing with rulers though is you have to be careful because you can't always see the points underneath the ruler. So you could use clear ones or use a spaghetti noodle and then a ruler or a pencil. Lots of options. But yeah, so you determine the line or you try and find a line that goes through the most or best represents those points. And then to determine the equation of it, you find the 2 points on the line or closest to it and determine the equation by using the standard form, first by finding the slope of y2 minus y1 is equal to m times the quantity of x2 minus x1, and that will give you your slope, and then you can use one of those points and put it into the y minus y1 is equal to that slope we found, m times x minus x1 again. Okay. So this moves on to our next point, is a median line. Now this might be the concept that's new to you guys. And a median, I know it was for me, but a median line is just kind of a more precise way of finding a line of best fit, because and when I say precise, that usually means that there's a little bit more work behind it, but it makes it more accurately represents your data. So how do you find a median line? Well, there's about 4.5, 5-ish steps in finding a median line. Ooh, that's a mouthful. The first one is to take the data and separate it into 3 equal groups based on the x values. We're only going to deal with the x values right now because each x value is paired with a y value, but it just gets too messy if you do it all, so we're just going to start with the x values. With separating into 3 groups, obviously most things aren't divisible by 3, and in these cases you want to make sure that your first group, so the lower values, has the same amount of x values as your third group. So the middle one doesn't have to have the same amount if it's not divisible by 3, but the first and third do. But if it is divisible by 3, then you're set to go. It saves you that extra work. Okay, so now we're on to step number 2, and that is finding the summary point. And to do this, we have to find the median of each group. Oh, funny, we're dealing with medians with a median line. See how it all comes into play? I know. So, with a median line, you want to find the median of each group. So, the first group, the second group, and the third group. And with these, it's best to write down the median in the coordinate form so you have both x and y values. And then the third step is finding the slope from groups 1 and 3 of the medians. So you would take the y value of group 3 minus the y value of group 1 divided by the x value of group 3 divided by the x value of group 1. Then we move on to step number 4, and that is where we start to begin the process of finding the y-intercept. And to do this, the first thing you have to do is add the 3 y medians together. So the y median from group 1, 2, and 3. Find that sum. And then similarly, you find the sum of the x medians from the 3 different groups. And that moves on to the last step of finding our y-intercept of our median line. And we determine that by taking the y median sum, so the first number that you'd found in the last step, minus the x median sum, which is the second number in the last step that you found. And then you take that difference and divide it by 3. And that, ladies and gentlemen, is your y-intercept. So now you have your slope and your y-intercept, so you can put it into that y equals mx plus b form. Okay? So, now what we're going to do is we're going to open up some Desmos here. Let's see, I hope this works. And you click on Start Graphing once you get to Desmos.com. And then, let's see, we are going to move it over here a little bit. Alright, so now if you go up here in Desmos on the little toolbar is what I like to call this area, is click on the plus button and it says Add Item. And then the third option down, you go ahead to Table and click. And now it brings open a table for you. So what we want to do is what we can do is enter in some points. So, and the reason that this is relating to what I'm talking about today is because it's a good way to check your work. Because we all know that sometimes when we do a bunch of calculations, it doesn't always make sense. So this is a good way to double check, and another way to do it so you don't have to do everything on paper, And then we can make sure, you know, and what I'm doing making sense, or did my drawing get off a little bit, and did I miss a point? So let's just throw some points in here so I can show you. Let's say 3, 5, I don't know, 4, 6. And as you see, as I type in the points, the little green dots pop up on the other side. And you can change the color of the dots as we were shown before up here in this little thingy-ba-bing in the options. But this can make it disappear, and this can make it show. Anyways, but now what we can do with this, we can see our data points. And it should match up with the drawn one, or if you visualized it. And what you can do is when you determine what your line of best fit, or the median line, is you can plug it in right here so that you could determine, you know, is what I'm doing working out? You know, is my calculation finding, does it fit, you know, does it work the way I wanted it to? And if you do, and if once you graph it and you see how it works, you're like, oh, yep, everything's lining up the way I wanted it to, and then you know you're good to go. So, we jump back over here. Sorry if that was a bit redundant. You can look down at the bottom of your sheet, and there is a problem for you. I didn't write down the actual problem background because I wanted to make sure you watched the video, because that's how you're gonna know what to do. But what the problem on the sheet correlates with this, and it's you're hanging out with your buds in the backyard pool, and for some entertainment, one of your buds brought some swim diver toys where you throw them and they dive into the bottom of the pool. Your goal is to determine the best equation that will represent how fast the diver toys are diving. So you know those swim toys that you throw to the ground and you race with your friends to see who can get it first, and they win? Well, your goal here is to determine how fast that diver toy is swimming. So what I would like you guys to do is to fill out the rest of the worksheet, do it all by hand, and then on the last problem it says to go on Desmos. So go on Desmos, plot the data, put in the 2 different lines, see how they match up and how they're different, and then go ahead, take a snippet of that and print it out and bring it to class with you tomorrow. I will be collecting this, and this just so I can kind of see how you're doing it if you understood how it all works, okay? So that's all I have for you today, and all I have for you for this lesson. And yep, okay. This is Anna, over and out. Have a great night.